Okay, remember any odd degree polynomial is going to take the shape of this, right? Now, depending on the degree, like it might be x, this is x to the third. If you get an x to the fifth, x to the seventh, it all depends. This is x cubed. It'll just increase the number of bumps. Okay, this is probably x to the fifth, so on and so forth. When we have an even, polynomial, we're going to have some kind of parabola, right? That's x squared. And depending on the number, again, suppose we have x to the fourth. Again, it's just going to be adding another bump in there. X to the sixth is going to be a bump. So we're either going to have this shape or this shape when we graph polynomials. Right. Now, I would expect x cubed for it to be this function, which is what we got. So the first thing we're going to do is find the x-intercept, or the zeros of the polynomial. There's sometimes they're called roots, sometimes solutions, zeros, all kinds of names for these x-intercepts. And the way we do that, well, I hope you remember, we're going to go back and use second trace to find the zeros. Okay? So I'm going to go with second trace. I'm going to go down to zeros, highlight the zero, hit enter. Hopefully this will come back to you. Now I'm going to find that first zero, so I'm going to get to the left of that zero. So here's my left bound. I'm going to hit enter. It's asking me for the right bound, so I need to get to the right of that, or the opposite side of the x-axis. Going to hit enter, and then I'm going to hit enter again to get the number. Now the intercept, my y values are always 0, so I'm just going to put down the x 0, okay? And it happens to be negative 1.79. So I have negative 1.79. And I know from the fundamental theorem of algebra that it has 3 zeros. So I'm going to go to the next zero. Same thing. Going to go second trace, next zero. And I'm going to get to the left, get a little closer to that zero. Here's my left bound, hit enter. My right bound, hit enter again. And my next zero is going to be at 0.11. 0.11. One more zero. Second trace, 0. Got to get closer to that other zero. Left bound, enter. Right bound, enter. And that zero is going to be hit enter again at 1.67. So 1.67. Now notice that my y isn't 0, but it's kind of like a pixel thing for the calculator. This is actually at 0.000000000012, which is 0. Okay? It's just putting it in scientific notation. All right, then I got to find its relative max and min. Okay, these are that's the max, relative max, and obviously that's my relative min. So I need to find where those are. For my relative max, go back to your second button, second trace. I'm going to go and find the maximum. So I'm going to hit number 4, max. So I need to get my cursor back to the left of there for the left bound. Hit enter. Need my right bound. Hit enter. And then hit enter again. and my max is at -1, 7. -1, 7. Okay, next thing I need, my minimum. So I'm going to go back to second trace. I'm going to do my minimum, enter. Get a left bound, enter. A right bound, enter. Enter again. And my minimum's at 1, -5. So 1, -5. So now I'm going to draw my graph. My zeros. I have -1.8. So -1.8 is almost -2. Positive 0.11, so just over 0. And then 1 2/3. So here's 1 2/3. There's my 3 zeros. Let's see, I got my max, -1, 7, and my minimum, 1, -5. Now, with any luck at all, I can draw my graph. It's going to be coming from -infinity. It's going to come through that first 0, hit my max, that's my first turning point, come back down through the second 0, hit the min turning point, and go back up. Let's try this. I'm going to be coming from -infinity, through the first 0, hit the turning point max, then through the second 0 to the turning point min, then through the third 0. Okay, there's my graph. Not too bad. Okay, increasing and decreasing. Now, for increasing, where the function increases and where the function decreases, we're looking at the domain or the x-axis. So I'm looking at the x-axis. Where is my function increasing on the x-axis? Well, I'm going to use my blue increasing. So I'm looking at my function, and starts down here. It's coming up from infinity, right? It's increasing, 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 increasing all the way up to the turning point max, which, if I look at it, my x value for the turning point max is -1. So it starts out from -infinity, keeps going up until it hits the turning point x value, because I'm looking at the domain. And that is going to be, I'm looking at my max x value, -1. Okay, so here's my increasing, my first section. Then it hits that turning point and it starts to decrease, right? So again, I'm at my max x, so it starts at -1, decreasing, and it's going to go to the x value of the minimum. Stops decreasing. Okay, so it stops decreasing at the x value of my minimum, and that happens to be 1. Then it turns around and starts increasing again, right? From the x value of my minimum, starts increasing again all the way up to positive infinity. So from the x value of my minimum, which is positive 1, it increases to infinity. And since I got two intervals there, I need my union sign. And since that's not enough fun for us, let's look at our end behaviors. You guys remember end behaviors? The f of x or y approaches blank as x approaches negative infinity or goes to the left. Y approaches blank as x approaches positive infinity or goes to the right. Let's look at this. We start at the origin, and as x goes to negative infinity or to the left, my graph goes down to negative infinity. Start at the origin, and as my x goes to positive infinity or to the right, my y approaches infinity. So we really analyzed that graph a whole lot. Questions? That was so much fun. Let's do another one. A whole lot of enthusiasm in their faces. Let's look at the back. Let's do number 5. Okay. Let's do number 5. Okay, this one, actually, this is in factored form. Okay. If we were to multiply this out, we would have an x to the 4th, right? So I'm expecting some kind of parabola here. Now, these, we know what the zeros are. We don't even have to graph this to figure out what the zeros are because it's in factored form. Remember, we set each one of these equal to 0 to get the zeros? So if I set x minus 3 equal to 0, I get positive 3, right? But since it's squared, this has a multiplicity of 2. Remember we talked about that? So it's going to come down to my x-axis, and it's going to bounce off instead of going through it. That means it's got a multiplicity of 2, and it bounces up. And the same with the other zeros. Okay, I have a negative 1. That also has a multiplicity of 2. So those are my 4 zeros. It just so happens that I'm only using the points 3 and negative 1 because they count twice. All right, so let's go ahead and put this in our calculator, and we're going to have to find the max and min so that we can graph it. Now, it's going to be some kind of a parabola because it's x to the 4th. So I got 1/2. Make sure you put fractions in parentheses. 1 divided by 2. Then I've got the quantity x minus 3 squared times the quantity x plus 1 squared. Okay. You can graph it. And I have a double bump parabola, x to the 4th. Okay. So I know what the zeros are. They're 3 and negative 1. So 3 and -1, and they're going to bounce off of that. We need to find the max and the min, right? Okay, this one has actually two mins. So let's find the mins. First min, I'm going to hit second trace, minimum, enter. Going to get to the left of that minimum, hit enter. Get to the right of that minimum, enter, enter again. And it's at -1, 1.28. So this minimum is at -1, 8.28. Okay. Next, I'm going to find the max just because it's the next thing on the graph. So I'm going to go second trace. I'm going to find the max. I'm to the left, hit enter. I'm going to go to the right, hit enter, and enter again. And that relative max is at 1, 8. And then I've got another minimum to find. So I'm going to hit second trace, the next minimum, and hit enter to the left, enter to the right, enter for the actual number, 3, 0. So I have another minimum at 3, 0. That's that scientific notation again. It's the pixels in the calculator are giving me a very, very tiny number, but it's 0. Okay, what's next? Graph it, right? All right, my minimums. Let's see, -1, 8.28. No, this minimum should be 0. This was probably scientific. Put our 0 there. That was probably 8.28 times 10 to the -12 or something like that. It's 0. So -1, 0. Our maximum, 1, 8. The maximum. And then our other one is our other min, 3, 0. Okay. Let's see if we can graph it. So it's coming from positive infinity. It's going to hit my first 0 at -1, bounce. So it's going to turn my graph, turning point, back up to my maximum at 1, 8. Turn it back down to my other minimum and 0, 3. Turn it back up, and there's my graph. Okay. All right, so now we got to find increasing and decreasing. Increasing, decreasing, and we might as well go ahead and do our end behavior. The f of x approaches blank as x approaches -infinity or goes to the left, and the f of x approaches blank as x approaches positive infinity. All right, so decreasing. My graph is actually decreasing from positive infinity to the first turning point or 0, which are the same, where the x value, let's see, minimum is -1. So it's coming from positive infinity, decreasing till it hits that minimum, and the x value for the minimum is -1. And it starts increasing from the x value of that minimum to the x value of the maximum. So from the x value of the minimum, which is -1, to the x value of the max, which is +1. And it starts decreasing again. From the x value of the max to the x value of this minimum. So from the x value of the max, which is 1, to the x value of the second minimum, which is 3. So there's 2 intervals for decreasing. Then it increases lastly from the x value of the second min to positive infinity. So from the second min, the x value, 3, to positive infinity. Okay, my increase and decrease. All I have left is end behavior. Start at the origin. As x goes to negative infinity, or to the left, my y goes to positive infinity. And as my x goes to the right, the end of my graph goes towards positive infinity. Isn't that fun? Pardon me? Can't hear you. Very boring. Wow. Breaks my heart. I thought this would be one of the funner things you do. Ah, I was completely wrong. Huh.